So Joe has joined us, from the US, from NREL, and he'll be telling us about considerations for transforming energy technologies, lessons from introduction of metal halide perovskites, photovoltaics. Yeah, the stage is yours.
All right, I will try to keep on time. We'll see how I do.
Okay, thank you.
Excellent. All right. Well, thanks for the opportunity. For these talks, I always like to really start out by thanking my colleagues. Up here. Hopefully, you can see my pointer are my co-PIs and co-conspirators at NREL working on photovoltaic technologies. Of course, I want to thank the funding agencies. U.S. Department of Energy is a big sponsor of our work. But in addition to these co-PIs that are at the top, the people who really do the work are shown here at the bottom. In particular, today I'm going to be highlighting work that's where all of these folks have contributed significantly to advances. And then we do have a lot of wonderful collaborators that we work with routinely as well. In addition to those kind of more traditional kind of collaborations, we also have a lot of industrial partners, as well as a number of universities working a little bit more at the sharp end of the technology, so to speak. University of North Carolina, Chapel Hill, Jinsong Huang in particular, University of Toledo, Yanfei Yan, Keep, and others, and then Washington Energy Testbeds, Devin McKenzie and David Ginger, as well as these companies. And you can find more out about some of the things that we're working on and targeting at this link here, as well as some webinars that different folks from these companies have put out about their activities related to metal halide perovskites. So I want to start out kind of just reminding people, if they probably already know, but solar energy generation approaches are actually a portfolio of things, right? It's not a single technology. There are solar fuels, there are concentrated solar power, and there are photovoltaics. And these days the lines between these technologies are starting to blur in some interesting ways. But for today, I'm really going to focus on kind of PV, because that's where a lot of our metal halide perovskite work is currently focused. But when you talk about a PV system, it really is more than a cell, right? The modules are, of course, the thing that we often focus on in the cells, but they aren't any good without the rest of the system, right? Whether it's for a residential application as shown here over on the right, or really kind of grid tie as shown on the left. And one of the things that it's really nice to keep in mind, and it's especially useful working in a place like NREL where you have people that worry about all the different elements, is asking, what's the goal of a solar technology? And it really is to address climate change, produce clean energy in a sustainable fashion, preferably at a net CO2 deficit, right? That's really the goal. And I'll also point out that, we can make a transition between CO2 costs of things and energy, understanding kind of how we generated that energy. So focusing in on photovoltaics again, right? Photovoltaics are really semiconductors. All the different technologies that we have, and I'll show the requisite NREL chart, but this is a list of all the different PV technologies that NREL does keep the record cell efficiencies for. Photovoltaics really convert photons directly into electrons and holes. And so they're based on semiconductors. So there are challenges that happen at both the system level in terms of basically dispatchability. That is to say, we want the energy to use the energy when we want it. So things like storage is really critical, not simply when we're during the daytime if we're terrestrial. I hate to say, right, PV only works when the sun is shining, because it turns out the sun is always shining. Whether we have access to the sun is maybe another question. But that does make, for terrestrial applications, dispatchability critical. Durability is also an important consideration. I'll talk a little bit more about why. But then the other challenge is actually existing grid infrastructure, right? When we put these resources on the grid, that also can create some challenges for how we manage energy more generally, in electricity in particular. So at the research level, there are systems level considerations where we're doing active research at a place like NREL. There are quantum approaches that are kind of really low TRL that can kind of beat the conventional limits of PV performance. But a lot of what we're doing these days are looking at new materials. And in the case of new materials, sometimes this also couples to, can we make things lighter weight, higher power to weight ratios? But if we back up and think